Welcome to this video tutorial from SPSSVideoTutor.com. I'm Jacob Mays, and today I'm going to demonstrate how to perform and interpret a mixed design analysis of variance. In this example, there are 60 students who are extremely fearful of statistics. There are two intervention programs designed to reduce fear of statistics in students: the Math Skills class and the Confidence Building class. An equal number of students were randomly assigned to each class. Students in both classes were given the same fear of statistics test 3 times. Once before the intervention classes begin, the second directly after the intervention classes ended, and a third 3 months later. Okay? We want to know two things. First, is there a significant difference in statistics fear scores between the two intervention groups? This is our between subjects comparison because we're looking for the differences between the two groups. Second, we want to know if there is a significant difference in stat fear scores across the 3 time periods. This is our within subject comparisons because our measure is repeated with each person. All right? So the first thing that we do is we go to Analyze, General Linear Model, and then down to Repeated Measures. Under Within Subject Factor Name, we type in the name that best represents our repeated measure. Okay, so ours is Fear of Statistics Test, so we're going to type in Stat Fear TST for test. All right. The next thing we have to fill in is the number of levels. And this is essentially the number of experimental conditions. All right. So in this case, we have 3 experimental conditions. We have test 1, test 2, and test 3. So we type in 3, and then we click add, and then we click define. Now, the first thing that we do is we move each of our 3 repeated measures into the within subjects variables box. All right, and we have to move them in order. So the first test goes over first, the second test goes over second, and the third. All right, the next thing that we do is we move our between subjects variable group into the between subjects factor box. All right, next we go to plots, and we move our repeated measures variable, which in this case is stat fear test, into the horizontal axis box. And then we move our between subjects variable, which is group, into the separate lines box. Now, if we had another repeated measure, we would move the second repeated measures into the separate lines box, and then the group measure into the separate plots box. Okay? But in this case, we're just going to keep it as is. We're going to click add, and then we'll click continue. Now, post hoc, if your between subjects factor has 3 or more categories, okay, then you would use post hoc. You would move your factors over into the post hoc test, okay, by highlighting it like this and doing this, and then you would select LSD, Bonferroni, depending on your professor's preference, and then Games Howl. All right, and then click continue. But since our group only has 2 categories, the math skills and the confidence skills class, we don't need this, so we're just going to click cancel. Next, we go to options, and we're going to move each one of these over into the display means for box. All right, so group, stat fear test, and then the interaction group stat fear test. We click on compare means. Under confidence interval adjustment, we go down to Bonferroni, and then we click descriptive statistics, and then homogeneity of variance, and then we click continue, and then we click OK. Now, there's a lot of output that you're going to see, but we're only concerned with certain tables. All right. So the first table that we see is the within subject factor. This just tells us what 1 represents under stat fear test. So 1 represents fear of stats 1, 2 represents fear of stats 2, 3 represents fear of stats 3, which is the third and final test. Under between subject factors for type of class, 1 represents math skills, 2 represents confidence building. All right? And then we have the descriptives table, where we have the mean and standard deviation and number of cases for each variable and each factor within the variable. Okay, so for our first test, fear of stats time 1, we have the mean scores for the math skills class, the mean scores for the confidence building class, and then the mean score across both classes, which is a total 40.17. All right? The next thing we do is we go down to Mauchly's test of sphericity. All right? And what we're concerned with here is the value under significance. Now, if this is greater than 0.05, then the assumption of sphericity is not violated. All right? Since it's less than 0.05, then the assumption of sphericity is violated. All right? Now, we go down to the next table, which is our ANOVA table for the repeated measures, or the test of within subject effects. Now, since our Mauchly's test significance value was less than 0.05, we have to use the row labeled greenhouse geyser. Okay? So when we're writing our results, we have to make sure we use the degrees of freedom and the F value from the greenhouse geyser row. Now, if this was greater than 0.05, our Mauchly test was greater than 0.05, then we would use sphericity assumed, and we would use the degrees of freedom from the sphericity assumed row. Okay, so that would be 2, and then our F value obviously would be the same. And we would do the same thing under our interaction. Okay, we have to use the greenhouse geyser correction because our significance value in our Mauchly test was less than 0.05. All right, so we look under the significance column and we see that for the greenhouse geyser row that our value is less than 0.05. This means that there is a significant difference in the scores of our repeated measures. Now, we don't know which scores are different, we just know that there is a difference. So we have to look at our pairwise comparison test to see where the differences actually are. Okay, next we look at our interaction. Okay, is there an interaction between stat fear test scores and our groups? Again, we look under the greenhouse row and we go all the way over to our significance value and we see that it's 0.134, which is greater than 0.05. So there is no significant interaction between stat fear test and group. All right? Now, we go down next to Levine's test of equality of variance. And here we're testing for homogeneity of variance. All right? If this value, if any of these values under significance were less than 0.05, then that means the assumption of homogeneity of variance has been violated. And we probably have to consider running some kind of data transformation on our variables to get that in line. But since it's greater than 0.05, then we have met the assumption of homogeneity of variance and we can move forward with no problem. Now, here we come to the test of between subject effects. This is our ANOVA table for our group variable. And we see here that in the second row, okay, we have a significance value of 0.810. This is greater than 0.05. So that means that there is no significant difference between our two groups, meaning that there is no significant difference in fear of statistic scores between our confidence class, and our math skills class. All right? So then we move down to our estimated marginal means. This gives us the mean, standard error, and our confidence interval for both of our categories in the group variable. So we see that our mean score for the math skills class was 37.867, and the mean scores for our confidence building class was 37.400. And as we saw above, there's no significant difference between those two groups. Now, we have our pairwise comparisons. We already saw that there was no significant difference, and this just confirms that. Okay, so then we go down to our stat fear test. We have the mean, standard deviation, and the confidence interval for each of our three tests. Okay? Now, to see exactly where the differences were between our three groups or our three tests, we don't go down to the pairwise comparisons under stat fear test. Anywhere there is an asterisk, that means that there is a significant difference between those two groups. So here we have group 1, which is test 1 compared to test 2. And we see, since there's an asterisk, that there is a significant difference. Okay, we can look under the significance column and see that it's less than 0.05. Okay, same thing for 1 versus test 3. There's an asterisk there. The significance value is less than 0.05, so there's a significant difference between those two groups. In fact, there's a significant difference between all of the groups. So in order to interpret this, we go back up to our means table, and we see that group 3 or test 3 is significantly lower than test 2 and test 1. All right? And test 2 is significantly lower than test 1. So in layman's terms, participation in the intervention programs resulted in a decrease in fear of statistics over time. Okay? Now, if you look at the profile plots, we see this graphically. Here we have the fear of statistics scores at time 1, time 2, and time 3. Okay? Now you know how to perform and interpret a mixed between within subjects ANOVA in SPSS. If you have any questions, please submit them to jacob@spssvideotutor.com. This has been a video tutorial from spssvideotutor.com. Thank you for watching, and much success with SPSS.